everyone, in this video we go through the solutions of the Hour of Power. So 20 questions, let's try not make it too long. I've just finished off a methods video and I'm a bit tired, so I'm going to ask for forgiveness before I've even started because I am umming and ahhing and thinking and a little bit, very tired and a little bit brain dead. But anyway, let's move on. Alright, which one of the following sequences shows the first 5 terms of an arithmetic sequence? So remember, an arithmetic sequence has a common difference, so it has to go up by the same amount. During reading time, I would spot this question and know straight away what the answer was. So, because you can do it in your head. So for the first one, we're going up by 2, then it goes up by 6. So definitely not that one. Goes up by 2, then goes up by 4. Nope. This one here, we are going down by 5 and then going down by 10. Oh, sorry, no, what am I doing? See, we're going up by 5 and then we go up by 10 and then 5. So it's not that one. So here we're going up by 3 and then we're going up by 3 again, 3 and 3. Beautiful. And we just double check that, I haven't made an error. Going up by 2, then 5, so definitely D. I do have the solutions, but I just need to flip my computer around because I've got on a post-it note on the other side, so I should really check. And I can, have I written them down? Oh, I was going to say I've written down the percentage that got it right, but I didn't. Something else I jotted down. All right, question number 2. The first 3 terms of a geometric sequence are 6 something and 54. So basically we've, geometric means we're multiplying by a common factor. So we're going from 6 to something to 54. So think about what I would need to multiply 6 by to get this number. So you can have a fraction. So we just take 2 consecutive terms. So if we're doing 9, it would be 9 over 6. And I already know that 9 over 6 times 9 is not going to give me 54. Again, I could do this during reading time, or you could do it on the calculator. So this one is 15 over 6 times 15. Again, not going to give me 54. You could check this on your calculator. 18 over 6. Now that does simplify to 3. So 3 times 15 does not, sorry, not 15. 3 times 18, I was looking at the previous question. 3 times 18 is 54. So the answer is C, and you could go on and do the other questions as well. So it's just looking for the common ratio, which I did here, and I could do the other 2, and then multiplying it by these numbers here, because that would be X. All right, question 3. 4,000 is invested in at a simple interest rate of 5% per annum. The amount of interest earned in the first year is, so it's per annum. Oh my gosh, this question is super easy. So we're just doing 5% of 4,000. So on your calculator. All right, hopefully this isn't going to move you up. So, it's 5. 5, oh gosh, do I do an extra 0? 5%, 5 over 100, and then multiply it by 400, or 4,000. All right, so we get 200. So the amount of interest earned, just make sure we've read the question properly, because sometimes it's like, oh, is that too easy? And yeah, it's easy. Question 4. A photocopier is depreciated by 4 cents for each copy it makes. So it's an example of unit cost depreciation. 3 years ago, the photocopier was purchased for $48,000. It's now worth $21,000. So the total number of copies. So we're doing 48,000 minus 21,000. So we're going to work out how much it's actually depreciated by. So if we did that in the calculator, we get 27,000. And that's over 3 years. So we want to work out, oh no, we're doing it for the whole 3 years. I was going to calculate it for a year, but we want to do it for the 3 years. So 27,000 divided by 0.04 All right, so 27 divided by 0.04, and we get that big number, 675,000. So if it was per year, we would have to then just divide that by 3, but it's over 3 years, so we didn't have to do that. All right, question 5, for the geometric sequence, the common ratio. All right, so we take the second term and divide it by the previous term. So that's going to give us 1/4, and as a decimal, that is 0.25. Question 6, a car is valued at 30,000 when new. It is depreciated by 25 cents per kilometre. The number of kilometres the car travels before it depreciates to 8,000. All right, my son's just got home, so he's going to probably come in soon. I'll have to pause the video. All right, so 22,000. And, oh, we're only going to do 22,000 divided by 25 cents. So do 0.25, plug that into the calculator. Here he is. All right, so that was 88,000. Moving along. A sum of money is invested in an account paying simple interest at a rate of 8% per annum. The total interest earned on this investment over 6 years is 27,000. The sum of money invested is. All right, so we've got 6 years is 27,000. It is simple interest, so it's the same amount each year. So basically we're doing 8% of our principal value is equal to 27,000 divided by 6, right? Because it's 6 years is the amount of interest earned. So we want to solve for PV. So let's just write that 8% as a decimal, and PV I'm going to call X, and we can just keep that as a fraction. So X is equal to 27,000 over 6 times 0.08. Now you could put this into solve on your calculator. You don't have to solve it by hand, but still a good idea to be able to do that. All right, so 27 divided by 6, because we wanted it per year, and we're going to multiply that by our interest rate, which was 8%. All right, so 360. Oops. I knew I made a mistake, so I was just trying something else, and then it's like 360 is not there, and clearly it's not. So I was like, oh, where did I go wrong? So here, and I wouldn't have got this wrong if I did solve. So this is what I did wrong, guys. I multiplied by 0.08. So to get rid of that, remember we divide. So I should have put divide there. Silly me. All right, so let's go back onto the calc. Go to divide, and then we should get the answer. So if you, it's probably a good thing that that answer wasn't there. Also doesn't make sense. How could you, an investment go from, what was it, 360 to 27,000? All right, so $56,250. All right, so just making sure that was divide there, not multiply. All right, moving along, $10,000 is invested at a rate of 10% per annum, compounding half yearly. The value in dollars of this investment 5 years after 5 years is given by. So it's compounded. All right, so you can see we don't have just a value. You can work out the value and then work all of these out, but this is just the rule being applied. So your rule is, where are we? So we've got our R to the power of N times V0. So that should be on your formula sheet. So R is 1 plus our annual interest rate, which is 10 over 100 times the compounding period. So it's half yearly. So it's going to be times 2. And I'm just going to put that in brackets because that's just one number. And then we multiply by our initial value. And N was 5 years. So how many compounding periods? So that's going to be 5 times 2. All right, so it's got to be 10. All right, so this is going to be 1.05 to the power of 10 times 10,000. I did 1,000 before. All right, you can see it's just the other way around. So basically anything that doesn't have a power of 10 I would get rid of, and we can see our value of r does not include that one, so it's got to be d. All right, so 8d. So a bit of a tricky one, just plugging it into the rule though for compound interest. So I think the main thing that would get students is this part here. So having 10 there, because remember that's the number of compounding periods you have, and also making sure that 2 goes there because it's half yearly. So compounding twice a year. All right, question 9. A computer originally purchased for $6,000 is depreciated each year using the reducing balance method. So that's an example of geometric decay. If the computer is valued at $2,000 after 4 years, then the annual rate of depreciation is closest to. So you can actually do this on Financial Solver. So I think I might need to open up a file, so I'll just quickly pause. All right, so just looking at your formula sheet, so we do have reducing balance depreciation. You could do a recurrence relation or the rule. All right, but I'm going to show you using Financial Solver for a lot of things. So we're doing reducing balance depreciation. So you can see N is the number of years, I is your interest rate, but it does have to be negative. It's the only application where it's negative. Principal value is also negative, payment 0, future value is positive, and PYCY is 1. All right, so we're going to put all that into the calculator. So going to menu, then going to financial, and clear whatever you got in there. All right, so we're doing it for 4 years. I'm just going to flip my computer because it's going to be a pain in the bum. All right, so 4. The interest rate is what we're calculating, so we'll leave that for now. We're not, so when something's depreciating, you don't add anything to it. Oops, sorry, that's there. PV, I just saw the P. So it's negative, so remember it did say it was negative on the sheet. And then 1 and 1, and your future value is positive, so 2,000. All right, so just double checking that. So depreciation, so principal is negative, future value is positive. All right, so your interest rate should come up as negative. So what is it closest to? It's closest to 24%. Now, so we just ignore that negative sign. That's just something you put into the calculator. You might want to read it as, you know, depreciating is negative. That's why it's negative. But we don't say it's negative 24%. All right, moving along. Question 10. Sam and Charlie. Sam turns up so much. Like, I've never noticed, but Sam is always around. Sam and Charlie each invest $5,000 for 3 years. Sam's investment earns simple interest at a rate of 7.5 per annum. Charlie's investment earns interest at the rate of 7.5% compounding annually. At the conclusion of 3 years, correct to the nearest cent, Sam will have. All right, so let's work out each one individually. So we'll do Sam on this side, and we'll do Charlie on this side. All right, so Sam is simple interest at a rate of 7.5% per annum, and we're doing it for 3 years. So on the calculator, all right, so 7.5%, so 7.5 over 100, just to turn it into a decimal, and multiply that by 5,000. So he's getting $375 interest each year. Let's multiply that by 3. So he earns $1,125 in interest. So interest is $1,125. You can add that on, so he basically ends up with $6,125. after the interest is added. Now with Charlie, because it's compound interest, I prefer just to do it straight into the financial solver, probably quicker to do it elsewhere, but you know, just financial solver is something that's probably that you haven't used much, so probably a good idea to start using it. All right, Charlie's is compounding annually, so it's just 3, also 7.5%. Principal value, so they've invested, so it's going to be negative 5,000. Payment has made no payments, so 0. And future value is what we're wanting, and it's just compounding annually, so 1 and 1. So he's earned $6,211.48. All right, so if you want to work out the interest, Charlie had earned $1,211.48 in interest. So we want to know Sam will, so what's the difference between the two basically? I can just copy that number straight. Let's copy that back into our main screen. Then we can paste it. Take away, just drag that down. All right, and then if you get a funny answer like that, you're probably in standard mode, so just change it to decimal. All right, so 5,000. Oh gosh. Then you realize you made a boo-boo, so you should put a 6 there. All right, so Charlie earned $86 more, so Sam earned $86 less than Charlie. All right, moving along. Question 11, a loan of $300,000 is taken out to finance a new business venture. So we've got a loan. The loan is to be repaid fully over 20 years with quarterly payments of that amount. Interest is calculated quarterly on the reducing balance, the annual interest rate. So this should be a straightforward question. So just putting it straight onto Financial Solver. So let's go to clear. And as we, instead of going down on your Financial Solver, as you're told something in the question, then put it in Financial Solver. So a loan of $300,000. So that's going to be our principal, and it's a loan, so it's going to be positive. All right. The loan is to be repaid fully over 20 years with quarterly payments. So it's going to be 20 times 4. So 4 quarters in a year. And that's our payment. So because it's going back to the bank, it's got to be negative 6727.80. Future value is going to be fully repaid, so it's going to be 0. And payments per year, 4 and 4. So remember, it's asking for interest rate, so it should be the only one blank. You might be sitting there thinking, oh, but I've got future value and interest. Remember, if it's being fully repaid, your future value is 0. So your interest is 6.5%. All right, moving along. An amount of $800 is invested for 2 years at simple interest of 4% per annum. The amount of interest earned by the investment, oh my gosh, it's such an easy question. So simple interest should never be overcomplicated. So it's the same amount each year. So we just want to do 4 over 100, turns that 4% into a decimal, and we're going to multiply that by our $800. So $32 in interest each year. So we've put it in for 2 years, so we multiply that by 2, so $64. All right, question 13. A loan of $17,500 is to be, so it's a loan, is to be paid back over 4 years at an interest rate of 6.25% per annum, reducing monthly balance. So it's an example of compound interest. So monthly repayment. All right, so let's put all this into Financial Solver. All right, so I'm going to clear it again. A loan of $17,500, so that's our principal value, is to be paid back over 4 years. Now, it does say later on that it's a monthly payment, so 4 times 12. Interest rate is 6.25. Making payments, there is a payment made. We just need to, oh, wasn't there a payment? Oh, that's what we have to work out. And it's fully paid, so it's 0 and 12 and 12. Doesn't say that it's compounding, but the fact that it says monthly, reducing monthly balance, it's implied. So payment is nearly $413. We had a few B's in a row. Question 14 is also B. All right. Ernie took out a reducing balance loan. Good on you, Ernie, to buy a family home. He correctly graphed the amount paid off the principal of his loan each year for the first 5 years. The shape of this graph for the first 5 years of the loan is best represented by. So first of all, I know it's a reducing balance, so that means it's got to be curved. All right, so we get rid of anything that is not curved. All right. Now, I think I did this with a student and got it wrong. So we'll just, I've just realized what I've done. I didn't read it correctly. So I think I was looking at part E as being the answer. So you had your principal and then it was going down, but it's the amount paid off the principal. So your principal is reducing each time. So it's the difference between the principal value and the current value gets bigger and bigger each time. So even though your principal is going down, the difference between your starting value and then whatever the current value is gets bigger and bigger. So if you think about, you've borrowed, doesn't say how much he's borrowed. Let's say he borrowed 500,000. All right, and then here he's fully repaid it. So the difference, so remember it's the difference between the principal and the current value. So obviously it's bigger as time goes on. I remember when I looked at the assessor's report, this question was not done well either. So a bit tricky thinking about the amount paid off. So each year more and more comes off the principal value. All right, question 15. Robin takes out a reducing balance loan of 100,000 with quarterly repayments of that. After 7 years of quarterly repayments, she owes that. Correct to 1 decimal place interest rate. All right, so let's plug all this into our financial solver, clear it. Now remember, you can use this table here. I should probably use it a bit more often. I just know off the top of my head what to do, but we're doing a reducing balance and it tells you what should be positive and what should be negative. Okay. Alrighty, so taking out a loan, so it's positive. How much was that? 100,000. I think I need to add a 0. Interest rate is what we're calculating. All right, let's read it. Let's put it in as we go. Quarterly repayment. So this, oops, already put that in the wrong place, silly Billy. All right, quarterly payment. So 4 and 4. And payment, so if you're paying it back to the bank, it's got to be positive. And she still owes 80,000 in 7 years. So that's going to be positive there. And then N, 7 times 4. So 7 years times 4 quarters a year, and we want the interest rate. Oops. And if I get error, this is where I think, oh, do I need to put a negative somewhere? So this should have been a negative. I realized when I did it, I'm like, oh, that's probably going to be negative. The reason it's negative is because it's still money owing that you owe to the bank. All right, so 6.3%. All right, moving along. The first 3 terms of a geometric sequence are the 4th term. All right, so we get our common ratio first by taking the second value and dividing it by the first value. All right, so that's 2. If you did it, you could do that on your calculator. You can also see it's doubling each time, but yeah, with decimals it might be a little bit harder. So our fourth term, we just need to, so that's term 1, so it's first term, second term, third term, so we just need to double that, gives us 1. All right, a loan of $300,000 is to be repaid over 20 years. Interest is charged at the rate of 7.25% per annum compounding quarterly. The quarterly repayment, okay, back to the calc, clear. All right, a loan of $300,000, so that's positive. Repaid over a period of 20 years. So it's 20 years times by whatever we're compounding. So it's compounding quarterly, so times 4. And I'm going to put my 4s down there as well. We're fully repaying it, so it's got to be 0. And we're making repayments. Oh, that's what we're working out. And our interest rate is 7.25. I thought we were working out the interest rate. All right, so payment 7132.42. All right, moving along. 3 more to go. Ray paid $40,000 for new office equipment at the start of the 2007 financial year. At the start of each following financial year, she used flat rate depreciation. So it's an example of linear decay to revalue her equipment. At the start of the 2010 financial year, she revalued her equipment at $22,000. The annual flat rate of depreciation she used as a percentage. All right, so in 2007, it was $40,000. And in 2010, it dropped down to $22,000. So in 3 years, right, so 2010 minus 2007, it's given us 3 years, it's dropped $18,000. So per year, so it's $18,000 for 3 years, so that's $6,000 per year that it's depreciated. So if we want to work out the rate of depreciation, we just take that $6,000 and divide it by our original value, which was $40,000, and times it by 100 to turn it into a percentage. All right, so 15%. All right, so this looks a little bit different to what we've seen before. So Anthony invested $15,000 in an account. It earned R% interest per annum, compounding monthly. The amount of interest that is earned in the 3rd year of this investment is given by. So I know when it's, so what we've got in the bracket is our R value, basically. So R is equal to 1 plus little r, which is our annual interest rate, over 100 times our compounding period. So this part here is 12,000. So I can go ahead and cross out C and D because they don't say 12,000, basically. All right, so they're key features we need to look at. I can also see that it's compounding monthly, and it's the 3rd year. So we're dealing with 36 months. All right, so we can get rid of A, which has got the 3 and the 2, and basically anything without a 36 in it. So we're only left with B. All right, so we don't actually have to calculate anything. We just have to look for key features. So we want to look at the interest earned in the 3rd year. So in the 3rd year, we've got 36 months. In the 2nd year, so 2 times 12 gives us 24. So that's what the 24 is there. So looking at key features like that and just doing a process of elimination saves you a lot of time. All right, and last question. I'm not going to get it done in 30 minutes. So Teresa borrowed $120,000 at an interest rate of 7.67%, compounding monthly. The loan is to be repaid with equal monthly payments. She decides to repay the loan by making monthly payments of that. Which of the following statements is true? All right, so this is where during reading time you'd probably read these statements and think, do I actually need to do anything on my calculator? So let's read them. She will pay out the loan fully in less than 10 years. Have to use a calculator. Amount of interest that she pays on the loan will increase each year. So she's borrowing money and she has to pay. So that's not true. So if you're borrowing money and you're making repayments, the amount of interest actually goes down each time because the amount of your loan is going down. All right, after 4 years, the amount that she owes on the loan will be, I don't know, every monthly payment she makes reduces the amount that she owes on the loan by the same amount. No, because of the interest. So that's not that because it's compounding. Monthly payments of that instead of that will enable her to repay this loan in less than 9 years. Okay, that doesn't really make sense. Oh, okay, so if we change the monthly payment. All right, so let's check the 3 of them using Financial Solver. So instead of having to check 5, we only have to check 3. So let's see, she borrowed $12,000. So if you're borrowing, it's $120,000, I should say. It's going to be positive. Interest rate is 7.67. Compounding monthly, so 12 and 12. The loan is to be repaid with equal monthly payments. So she's making payments of $1,430. Just remember there's a negative there. And the future value, so that depends on what the statement is. So looking at the first one, she will pay out the loan fully in less than 10 years. So if it's being repaid fully, future value has to be 0. So N, okay, so it's 120 months. So, and she's got a little bit over that. So it's not going to be fully repaid in less than 10 years unless her final payment is greater, and it doesn't refer to that, so it can't be A. All right, part C, after 4 years, the amount that she owes on the loan will be less than $80,000. So we need to then look at the future value. So we're going to change N. So 4 years of 12 months, so 4 times 12. All right, and it says she owes on the loan will be less than $80,000. So it's actually more than $80,000 owing. So she still owes $82,891. All right, so it's not C. All right, and this is where you hope that it's E. Monthly payments of that will enable her to repay the loan in less than 9 years. Okay, so we want to put that back to 0. We're going to change the payment. So she's increased her payment by that amount and in less than 9 years. So we want our N to be less than 9 times 12. So 9 times 12 is 9, oh my gosh, how can I not do 108? So it would take 106 months. Oh, well, just over 106 months. All right, so the option is E. All right, there we go. Well done, guys. I think that was it. See ya.